I just want to make this quick video here over some common pitfalls to avoid in running a one sample hypothesis test. Now, we're going to go step by step and kind of talk about the things you need to watch out for. First off, when you do your hypotheses, make sure that you don't forget to put the little H with the O for the null hypothesis and the H with the A for the alternative. Now, if you're dealing with proportions, you want to base this on the true P equaling some value that they said was true. Maybe they told you 42% was true. And then the alternative could be either greater than, less than, or simply not equal to that 0.42. And then you got to read the problem to know which one it is. But a common thing kids do is they'll accidentally put P hat here. Don't do that. You need P's there. If you're working with the mu, the average, a means test, then you want the mu. Maybe somebody told you that the true mu, the true average was 300 milligrams or something. And again, the alternative would be that the true mu is greater than, less than, or simply not equal to that 300. And again, don't put X bar here. Some kids will make that mistake. Make sure you're using mu. So before you even run a hypothesis test, you should be identifying, is it a one sample proportion Z test? That's here. Or is it a one sample proportion mean test? T test. That's right here. So, I'm sorry, one proportion Z test or a one mean T test. Makes a world of a difference. So write that down. A lot of kids never even write that down like I ask. Write that down so you know. The next thing is your conditions. We have those nice scripts for the conditions. Just please make sure you follow those scripts. It does not have to be word for word, but it does need to have the basic idea of those three conditions with the main points in terms of what they're representing. All right, next up here, we're going to move on to the discussing the actual work. Now, if you're working with proportions or you're working with means, the work's going to look a little bit different, but really basically the same. Proportions is a Z, means is a T. So for proportions, you need P hat, means you need your X bar, sample average. Proportions, you need the standard deviation of your sampling distribution. Remember, sampling, what many samples would look like. That's the square root of PQ divided by N. Now, don't use P hat here. Do not use P hat here. Because remember, in a test, you're assuming that the true P that you were told in the problem is still true. Over here, we use standard error of the sampling distribution, and that is S divided by the square root of N. Now here, S comes from our sample, which is why we have to use a T, because we should be using sigma here, but we don't know it. So we have to use S, the standard deviation from our sample. If you need to use the calculator to find S, make sure you use the S on the calculator, not the sigma, because that the calculator is trying to find that incorrectly. And some people say, well, why aren't we just using S? Why do I have to divide by square root of N? Because this is representing a sampling distribution. I really highly recommend that for either one of these, you draw a picture with the true P in the middle or the true mu in the middle, and then you go up or down by your standard deviations, because a picture really is worth 1,000 words. It really helps you see, did I see something special happen, or did I see something not special happen? Now, with proportions, you need a Z-score. That'd be your P hat minus that true P divided by that standard deviation. With mean, you need a T-score, which is your sample average minus the true average divided by that standard error. When you give me these, don't just show this part of it. I need to see this too. I want to see what you're finding. Again, don't just show me this. Show me what that is equal to. Show me that work. I want to see this work. I want to see Z equals. I want to see T equals. Then I want to find that P value. Here you need to use normal CDF to find that P value. Here you need to use TCDF. Don't forget with TCDF, when you're doing TCDF in your calculator, you have to have that extra comma at the end with the degrees of freedom. The degrees of freedom is your sample size minus 1. Now, don't just call this P. I see a lot of kids that they don't write dash value. They think that that's stupid or that's not needed. You need to write the P there because it's not a P. P might make people think you're talking about a proportion. No, no. P dash value is the samples. It's the probability of what that of seeing what you saw or more extreme. So so hopefully you keep that work, do that work, show that picture. Don't neglect to do any of that stuff. Now, last up is your conclusion. And the only thing I want to say about your conclusion is I'm assuming by now everybody knows how to make the conclusion. If your p-value is small, then you reject the null and take on the alternative. If your p-value is large, you fail to reject the null. So don't just say fail to reject or reject. Give me the answer to the question. Answer the question. The problem is usually going to ask something like, is there evidence of a change? Is there evidence that something has gone up? Is there evidence that something has gone down? Answer the question. If your p-value is small, then that is statistical evidence that there has been a change, whether higher or lower, whatever the problem is. If it's not, if you're going to fail to reject the null, that means there's not evidence of a change. Your null is still true. There's nothing else you could say against it. So make sure that when you give that answer, you actually answer the question. A lot of kids neglect to do that. They never actually answer the question. So like I promised you, a short little video that talked about some of the pitfalls and just some of the key things to avoid. That way you make sure you get full credit for a question. All right? All right, good luck, and I'll see you guys on Thursday, I believe.